cylinders. So we've done the 4 main ones now. We're on our last one, which is volume of spheres. Before we can actually do anything though, we're going to just label the parts of a sphere. So at the top, I'm waiting. At the top of your page, you see parts of a sphere there. So there's a couple different parts to it. First and foremost, a sphere is what you guys know, essentially a ball, right? So it's a solid that each point is equidistant, from the center point. So that means no matter where I go on this ball, the distance to the center of the ball is exactly the same at all points on this sphere. And so there's technically an infinite number of points on this sphere, and all of them go to the center, which makes this an equidistant, a perfect sphere. Okay, that's the definition of a sphere. Now there's a couple different parts to it. Number one, there's the part that goes from one edge of the circle through the center to the other edge of the circle. What is that piece called? Diameter. Good. So there's my first one right up here at the top. This is your diameter. It's the full length. And of course, you also know the other piece, which is half of it, which is the radius. So again, radius goes from the edge to the center of the circle is your radius. And so remember, that's half of the diameter. Okay. This part right in the middle is obviously, it's the center of your circle. So it's just called the center. So everything is equidistant, excuse me, from that point. And there's one more piece to the circle. It's called a great circle, or to another point to the sphere, excuse me. It's called the great circle. And a great circle slices a sphere into 2 hemispheres. In other words, if you look at this picture here, it kind of looks like this dotted line that goes all the way around. Essentially, it's taking my sphere and it's slicing it into my 2 hemispheres, right, that make up that piece. So if you think about the world, you think about the globe, what line would be our great circle? The equator, yeah. So that's the piece that's going to slice us in half. That's our great circle. Question.
So the great circle is shown in the middle. Could be anywhere on the circle.
Yes, it can be anywhere on the sphere. Doesn't necessarily have to be like left to right, right. It could be up, down, it could be diagonal. Because it's equidistant, there's also, again, an infinite number of ways to turn your sphere.
But you have the sphere and you cut it towards the top. Or you have bigger pieces.
Nope, great circle has to be in the center because the great circle divides it into 2 hemispheres. So it has to be in the center. Good question though, but it has to go through the center piece. Okay, so for volume of spheres, I think you're gonna love it because it's easy peasy. The only thing you have to do is plug in one number, and it's just a plug and chug into your calculator. So the volume of a sphere is 4/3 pi r cubed. And the only thing you have to plug in is your radius, right? Personally, I don't like to write it that way. I like to write it as 4 pi r cubed over 3. I just think that makes it easier when you go to put it in your calculator, but it means the same thing, okay? So all you have to do is be able to put it into your calculator, and then you're good to go. So let's take a look at number 1. You're finding the volume of the sphere. And in number 1, the only thing you need is the radius. And what's the radius in number 1?
7.
It's 7. So in our equation to find volume, we're going to do 4 times pi times 7 cubed divided by 3. So this is my radius cubed. Now, when you go to put in your calculator, the only thing that matters is you do it in the right order. What should you do first?
Cube the radius.
Cube the radius. Now, there's a couple ways to go about this depending on what calculator you have. If you want, technically speaking, you could do 7 times 7 times 7. That will get you there. That's fine. There's a couple other choices as well. If you've got my calculator, you push your 7 And then you can push the shift button and then the play button down here. And then that's the X cubed there. So you push shift and then that button. That's one option. Another option is to push, what I prefer is this X to the Y button, because that way you can put it to any power you want. So you would put 7 X to the Y 3. So that means 7 to the third power. And then you push equals. So then that way you don't even have to worry about the shift button. Okay. But it's up to you to kind of do it however you want. If you've got some calculators might have like a little upward arrow for you.
Oh, I see it.
If it's got a little upward arrow, that means like to the power of, you could put 7 and then the upward arrow, then the 3. But if you're using mine,
This one?
yep, that's the button. So if you're using mine, you're going to push calc, oh my gosh. You're going to push 7 X to the Y 3 equals. So if you're using mine, that's what you're going to push. If you're using your own, that's a little different. And actually, I think if you have an iPhone, I think it's also the X to the Y button as well. So you're going to do this part first because order of operations says we do exponents first. So you'll do 7 to the third power, which I got 343. And then you'll multiply times everything on top. So you'll multiply that number times pi and times 4. And then you'll divide that whole number by 3. So like I said, it's just a big plug and chug kind of moment into the calculator. And then you have to remember to divide by 3.
You get 1,436.
I did. Did everybody get that? Beautiful. So your volume for that sphere is, oh, I should put an about symbol, sorry. 1,436.8 inches cubed. Easy peasy. So it's all just, can you put it into your calculator correctly? Okay.
Did you put an about symbol if you just took a couple of decimal?
Anytime you round, you put an about symbol.
No, but you like don't round, you just like take the.
It's still technically.
It's still, yeah, anytime you round or anytime it's not an exact perfect answer that stops, you have to put an about symbol. Yes. Give it to me. All right, do number 2. Let's see if we get the same thing.
That's not.
Okay, you do number 2. We'll check it. We'll see if we get the same thing.
Does the user remember 1,000?
Yes.
Inches cubed, right?
Mm-hmm. One more second. I got a very big number for number 2. As big as a relative turned up. Things are all out. Sorry, friend. What'd you get?
I got.
You got it divided by 3.
Yeah, this is.
Did you do 16.5 first to the third power? You do that part first. Oh, how did I get 16.5?
Oh.
Why did I do that, Maddie? It's not the radius. I gave you the diameter. I gave you the full length. So yeah, definitely make sure, because you're going to see some problems where they give you the diameter and they hope you trip up. So don't fall for the tricks. That's okay if you fell for it the first time, but don't fall for it again. So learn from your moment. All right, that was spheres. Pretty easy peasy, don't you think? I think it's pretty self-explanatory. It's just plugging into a calculator is really the whole thing. Wait, what?
For hemispheres, would you do the same formula, but at the end you would divide it into by 2?
So you've got two choices. For hemisphere, that is one choice what Sarah just said. You can take the formula for sphere, finish the whole problem, and then take your answer and divide it by 2. That is definitely a choice. An easier choice is to do, instead of 4/3 pi r cubed, do 2/3 pi r cubed, because this is half, right? 4, 2, right? Hemisphere. So instead, you can multiply times 2/3 instead of 4/3, and that will give you the same answer. So why don't you do number 4 only, and then we'll flip it to the back. Okay, number 4.
So we have a test for all of this.
Yes.
We have formula.
No. I will give you what they give you on the test, which I think I showed you last week. I can show you again in a little bit, but it's not a lot. All right, so do number 4, and then we'll see if you get the same answer. Number 4, yeah, we're gonna skip 3. $18,816.57. Yep. And then when you're done with that last problem, just give me a little wink or a head nod or something. So I know you're good with that one. Yes.
Because I went ahead and did this because I forfeited.
Mm-hmm.
So I think we.
Yes, you did. Perfect.
Because I saw the formula, I'm like, oh, that's.
Like, I could do that. Yeah. Okay. What'd you get for number 4? Beautiful. Centimeters cubed. Yes, wonderful. So don't fall for the trick again, right? They give you the diameter, which is 12.2. So the radius is half of it, 6.1. And then we plug it in. You get 475.39 or 0.4, whatever, if you rounded it up. Nicely done. And that's it. Now you've done spheres and hemispheres. Did you do 6.1 for the radius? You used the diameter again, didn't you?
I did. I just need one formula.
Well, that would also make it problematic. Be a hard thing to do.
I don't have to erase anything.
All right, now flip it over to the back. We're going to do some application problems, and these are the ones that you're going to see on your final application problems. Not that I've looked at your final because that's illegal, but you know,
It is?
these came to me in a dream one night.
But you can't look at mine. But you make the formula.
No, it's a state exam.
For number 4, was it 475.38?
Look at it.
No, of course not. I would never.
Try to divide it by 2.
All right, let's take a look at number 6. So we're gonna skip 5. We're not doing it. We're gonna use that space though, so don't write in it. All right, number 6 says find the volume of the composite figure to the left. So what you'll notice, composite figure again means you've got more than one shape is a composite figure, more than one 3D shape. So in number 6, there's 2 shapes there. What are the 2 shapes you see? Hemisphere and a cone, exactly. So we're gonna find individually the volume for each one, and then what are we gonna do at the end? Add them together, great. So I'm gonna do, now, because they're 2 different volumes, I like to label mine as I go. So I'm gonna do the hemisphere first, and I'm gonna write volume of, and I'm gonna put Hemi right next to it. You could write HM, just put an H, I don't care, but do something so you know what you're doing, okay? Now, volume of a hemisphere is 2 pi r cubed divided by 3. 2 pi r cubed divided by 3. The only thing I need to plug in is the radius. What's the radius? No, it's not. 4.5. It's half of 9 is my radius right here. Okay, which means all you have to do is plug in. So take a second, just like before. I want you to plug that in into your calculators, and we'll see if we get the same thing. Correct.
How do you do the 4.5 to the third?
So this button here where it says, so you'll put 4.5 in, and then you push this button here, it says x to the y, and then you push the 3.
So
Put on what?
I got it.
Do you want us to round the volume of the
Let's do, don't you round to what?
Do you want us to round to the volume of the sphere?
Yeah, go to the hundredths place. Yes, Maddie, question. Pi is this button down here, it's EXP.
You can just press it, right? No.
Nope, you don't have to push shift, you just push EXP. There you go. Okay, well then try this one again and then see how you do on it. Right, you actually have to put in 3.14 on IXL only because they write in the description, use 3.14. That's the only reason. If they don't say that, like on the exam, if it doesn't say use 3.14, then assume you should push the pi button. That's a good catch there for sure. Okay, what did you guys get? Divide by 3, yep. So I got 190.85. Obviously meters cubed, but I'm just gonna leave that off for the moment. Are we okay there? All right, now, volume of a cone. You might have to look back in your notes. That's fine. That's why you have notes. What's the volume formula for a cone? Times height divided by 3. Awesome. Pi r squared h divided by 3. So r stands for your radius, h stands for your height, and we're just plugging our numbers in and using our calculator. So pi times, what's the radius of your cone? 4 point changed times, what's the height of your cone?
We don't know.
Why not A?
Because
Is it?
is measuring what is it? How do I describe that line?
Slant.
Slanted line. and
There.
not the actual height that's up and down. So
Beautiful.
you have to do the Pythagorean.
Oh my gosh, look at you. You got it. So look, here's what's A saying. Most people are going to put 13 for the height because they think that's the height.
No, it's the one.
And that's not the height. Yes, we're going to have to use the Pythagorean theorem for this one. So 13 is this slant. It's called a slant height, the diagonal height, essentially. It's a slant height. We need to know this one here. This is my H. That's the height I'm looking for. And then this is pretty much your triangle now. So you see that right triangle we got in there? So now we're going to do the Pythagorean theorem, the a squared plus b squared equals c squared. So this is why I said don't do anything up here. I'm going to come do my work up here.
Oh, so we don't have to do that?
No. Obviously, I'm going to have to come back down to this one, but here's my H. Here's my 13. What number goes down here?
4.5.
4.5. Very nice. It's the radius. It's not the diameter. Okay. So if those are my numbers and I'm using a squared plus b squared equals c squared, the only important one is the c. Which one's the c?
Oh, no, it's 13 because it's across.
It is the 13 because it's across from the 90.
We were not doing number 5, that's why we can use up there.
Correct.
Sounds amazing.
Wait, what?
So we're not doing number.
We're not doing number 5, so I'm doing the work for this one up here. Okay, what do I put in my A and my B categories? And nothing. You could put H, you could put B, put an X there. It doesn't really matter what you put. So I'm going to put 4.5 first. And then I'm going to keep it as an H just because height, so I remember.
Yeah.
Okay, now it's an algebra problem and you know what to do from here. Where should I go first?
You should go for the 13 time.
Okay, what's 13 squared?
2.6. No, it's squared. 169.
Weird, yeah, other way. You did the same, you said the same thing as him, so hush. Okay. You also have to do the 4.5 squared, which is what?
20.25.
Good, 20.25.
And take that and put it on.
And we're gonna move that to the other side by doing what? Subtracting.
Oh my gosh, it's good. And then we get 148.75.
Okay, so hold on.
on.
H squared is, what was it? 148.
148.75.
Okay.
Square root.
And then, yeah, last step is square root. Now you square root. Square root is the shift
Oh, and
x squared button.
and our height would be 12 point. Or 12 point.
You put 12.2.
But my-
Woo. Of course you can. You're okay. Of course you can. That's why they're there. All right. So now, look, we did all that work. We're not done. Oh my gosh. Now I have to take that 12.2 and plug it in for the height over here. I got to plug it in. And then divide that whole thing by 3. Woo! Okay, so take a second, find the volume of the cone. Let's see if we get the same thing. 2.
Did you get 6.98 out of 10,000?
No, 12.2.
What am I doing wrong? You must have run 6 times an hour.
No, 200th again.
So I got volume. The cone,
Volume of the cone is, what'd you get?
268.7.
Yeah. I did 0.71 just to keep it a little more exact.
Meters.
Yeah, I'm not even gonna worry about it just yet because, yeah, we're still not done. Our final step is you want to find the full volume of both of them So you do need to add them both together.
And we get 49,374.
I would hope you don't get 40 something thousand because this is 200 and this is 190.
I'm just playing.
449.56.
There you go. That
That's what I
sounds.
meant.
Yeah.
Same thing.
No, it's not, friend. Would you rather have $400 or $4,000? Because I'd rather have
Hold on,
4,000.
what am I doing wrong?
I
Oh,
don't know.
you added them. I'm timing them by like.
Oh, okay, there you go. There's the culprit. And then what's the label?
I gotta talk.
Look at you guys killing it. You don't even need me.
We done.
No, you don't.
Just playing.
Don't need me. I feel like you could do them all without me. Don't you?
Oh.
All right. That was a lot of work for one problem.
Not the steps, guys.
I am 100% positive they will give you a problem where you don't have enough information, like the height or the radius or whatever, and you will have to do a squared plus b squared equals c squared. They will never tell you that that's what you have to do. You have to know that. But I am positive you will have at least one question like that on your test, okay? So just keep that in the back of your brain, yes.
When is the math negotiate?
You know, I don't remember the date off the top of my head. It's a Monday. I think it's in 2 weeks. Because they hate us. The 16th? It's like literally 2 weeks. Yeah. It's a 2-day one, so it's a Monday, Tuesday. Super fun. All right. Questions? You ready to go on? Ready, Rommel? Why would number 7 be confusing? All right, let's do 7. Let's bounce on through. We're going through. We're going to finish them up. Number 7. The Henleys, go for it. No, read it. Go for it.
The Henleys have a silo
Yep.
on their farm to store grain. Assuming the entire stable used, what is the maximum amount of grain that the silo can hold?
Thank you.
This one easier.
Huh?
This one easier.
Way easier. I want to know total volume again, which means I'm going to have to do what?
5, 2.
A cylinder is a cone, or not a cone. Oh my God, a cylinder is like a can, excuse me. And a hemisphere. So you got to find the volume of both. And just like what we did before, you're going to add them both together. Now this time you're not going to have to do that a squared plus b squared, okay? This one's easier. Way easier. I'm positive. Trust me. When have I ever led you astray? Never.
When we had that partner quiz out of nowhere.
That was nice.
It was.
Just because you chose it, whatever partner you chose was up to you, man.
Yeah, I was bad.
That was not me. Maybe you should blame yourself for not being prepared.
The tournament was completely random. I didn't actually have a choice.
Oh well. Okay. Let's do the hemisphere first. Sounds easy. What's the equation for a hemisphere? Beautiful. Should be the easiest piece. What do we plug in for our R? 11. Good job. You didn't fall for the trick that time. Okay, so you put it in your calculator. Easy peasy. And tell me what you got.
1 sec.
Oh, I'll give you more than 1 sec.
2.
Ah, 100th is fine.
2,000, 27,000, 2,000. Gosh. Just can't get it out.
2787.64.
Oh my God, I just couldn't get it.
You're all good. 2787.64. Are we okay there? Okay.
Okay.
Now, the next one is a cylinder. How do you find the volume of a cylinder? Maybe you need to flip back in your notes if you don't remember.
IR squared.
Beautiful. Right. Okay, Kiana, like ready?
Yeah.
Nona? Okay. So again, easy peasy. We just gotta plug in some things. What's my radius? It's the same thing.
Radius is 11 and our height is
What's the height?
40,
But you gotta subtract the.
47. It's 45.
And
It's 45. Oh, it's your
8. What's 8?
Lie.
Why did I lie?
You gotta do something else.
Oh no, you don't.
Then what is?
Well, let's think about this logically for a second.
Oh, wait, so if you put the, can I,
Say it. Say
if you put the radius,
Uh-huh.
put it like, you know, like that?
Yeah, if I just turn it.
45 minus 11.
Dude, what? It would just be 11.
No, it would be 30.
No. So here's what she's saying. If you think about this for a second, right? This is the diameter, it's all the way across. The height, so that's this piece here on my ball, that's this piece
The
here.
height is
The height is, no, the height is from here to the top, which is the
Or
radius.
11.
No, the height is 11.
I just said that.
What did you, okay.
Because she said if you take the radius, you just turn it.
Right, so I'm taking the radius, I'm turning it. That's a radius. It's from the edge to the center. This piece is worth 11. The whole thing is worth 45. What does that mean the height of just the cylinder is? 34.
Wait.
We took the whole height, 45, and we subtracted the radius, 11. And that's where we get the 34 from. So now we plug in the 34 for our height. Now you just have to use your calculator and multiply. So take a second, multiply, and see what you get for volume of the cylinder.
Oh, that's wrong. I got it.
Got
Hold on, let me-
How do you say that number?
Oh, we got two to the edge.
I know how to say that.
Say it, Maddie.
1200.
12. Close. 12,000. Very close. Look, 1,200,000's got an extra zero in there. And if Mr. Math was making that kind of money, she wouldn't be here anymore, okay?
Okay.
Right? Well, I think you were.
5-1.
Mr. Masso.
There you go. And now, yes, last point is, right, you've got the volume of the hemisphere, you've got the volume of the cylinder, you're trying to find the total volume.
Hold on.
So you better add them together.
What are you doing? Divide by 30? That's right.
Because, you know why? Because it's a cylinder, not, if it was a cone, if it comes to a point, it's a divide by 3, but this isn't.
Okay.
So what do you get for your total volume?
Hold on. Okay, guys. Okay.
15,912.
You gotta add them.
You did.
Oh, wait, that would make no sense.
Feet
15,712.
cubed.
0.15218 to the 15,000. Yeah, guys, I did it.
Now you're just yelling numbers out.
Do you ever find it just refreshing to instead of putting it in your calculator, just write it out because you don't have to type it into your calculator?
What do you mean?
About actually just writing it out on your page and doing the addition that way.
No, I can't say I've ever found enjoyment in that. I personally prefer a calculator. Maybe even an
I
abacus.
just do that every once in a while because
Oh, not my jam, man. All right, we've got one more question. We've got just a few minutes. We got 8 minutes, so we're gonna breeze through. You ready?
Yes, ma'am, we
Okay,
are.
last one.
3 tennis balls
Go for
are
it.
stacked vertically. Top of the container.
Cylindrical. A cylinder.
Cylindrical container.
There you go.
The radius of each ball in the radius of the container is 4 centimeters. Determine the volume of the empty space in the container, the space taken up by the space taken, not taken up by the.
Not taken up by the tennis ball, so that's what's important. I'm stacking 3 spheres into a cylinder, but I don't want to know how much space these are taking up. I want to see what's left over, the unused space. I'm going to have to do some subtraction. Exactly. Now, let's do the sphere first because that one's easy. Let's find the volume of one of the spheres. That's easy peasy. And I'm writing down, it's just one sphere. Why am I only going to figure out one?
Because they're all match.
Yeah, I lost my 3 at the end, right there on that. Okay, so my volume of one sphere is 4 pi r cubed over 3. And what is the radius of the sphere?
4.
4. Okay. That would not be it, but good try. Okay, so do that. So 4 cubed goes first, then times pi times 4 divided by 3.
Got 2, 6, 8, 8.
Me too. Okay, now that's the volume of one sphere. You have
Times 3.
times it by 3.
804.24.
804 point what?
0.24.
Isn't it a number after? Isn't that a higher than 25?
Sorry. It's 2.5. Just write 2.
It depends if you left it like this, then it would be 0.4. If you kept the whole answer in and then multiplied, then it would be 0.25. Hey, that's my name.
What if we just didn't provide it?
Yes, 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 you're correct. Okay, that's 3 spheres. Now, you still need to figure out the volume of the whole container, the cylinder. It says cylindrical.
Use your context clues.
Yeah, it's like sharp edges.
Well, it's supposed to be, it's not like 3D.
And it says a cylindrical container. That's what.
Right, it literally says the word cylinder there.
And you can assume that because
I'm telling it to you.
Hell yeah.
Okay, now, we gotta finish up, hold on. Cylinder, volume of a cylinder is pi r squared h. Pi r squared h. Now, all you have to do is plug it in. What's the radius of my cylinder? It's 4.
So we got 16.
That would be 16. What's the height of my cylinder? A, what do you think?
it's 24.
How did you get that?
Because since you have the radius, the full diameter would be 8, and then because you can turn it over, it works.
Nice. So, here's what A is saying. They're saying, okay, if you have, so look up here, if you have your sphere, the radius is 4. That means the full diameter is 8. And remember, diameter can be left and right. Diameter can also be up and down. So the height of this one ball is 8. The height of this ball is 8. The height of this ball is 8. In total, your height is
8.
24. Okay. 24 is your full height. So now I'm going to plug in the 24 for my height over here. And I'll get the volume of my cylinder. Let's see, that's 16 times 24 times. And then I'm going to subtract them. Because remember, you're trying to find the remaining space.
So it's 1,206.3.
Yeah.
Yeah.
Yes, you're subtracting because remember, you're figuring out the remaining space, the space that's not being taken up by the spheres. So I take my cylinder and I subtract my spheres, and that's the remaining space. And just like that, you've finished your notes, you don't have any homework, and we're done for the day.
Being kind, Cindy. That's all.
Nicely done today, my dears. Please put your calculators back. And then one last thing, if you haven't been doing your IXLs, you're in trouble. And if you didn't finish your chapter 10, the second test that was due on Friday, which some people didn't, I extended it for a day. So if you didn't do it, you've got some homework tonight.
I got a C on it.
That's okay.
I always end up, and now he's second at it.
Are you reading the questions very carefully? Because I have a feeling you're probably putting in like the X when it asks you for a length and you actually have to plug it in.
You're just happy with me. I know this. It's like 9 no,
Oh.
I don't know what the answer is off the top of my head because everybody had a different test. So it's shuffled questions. So I don't know what your 9 and 10 was. Bye. Have a good day. See you guys tomorrow.